Hello everyone. Today, let's look at this interesting combinatorial question that's suitable for beginners. We'll look at the formal statement after showing some examples. We start with integers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's play a game. Choose 5 integers from 1 to 10. For example, 2, 5, 7, 8, and 10. After these 5 numbers have been chosen, I'll write it in an increasing order. For the rest of the numbers 1, 3, 4, 6, 9, I'll write them in decreasing order. So 9, 6, 4, 3, 1. After which, we'll look at each column. I'll take the absolute difference for the number in each column. First column, it will be 7. Second column, 5 and 6, the absolute difference is 1. Third, the absolute value of 7 and 4 is 3, 5, 9. After that, I add all this number and I get 25, which is equal to 5 squared. Let's try again by choosing some other 5 integers. So I may choose 1, 3, 8, 6, and 9. Write this in an increasing order. For the rest, write them in a decreasing order. Then 7, 5, 4, 2. Then take the absolute difference for each column, which is 9, 4, 1, 4, and 7. When you add up together, again, we'll get it is 25, which is equal to 5 squared. Now, this is your turn to choose any 5 integers from 1 to 10 so that you can write them in an increasing order. For the remaining 5 integers, write them in an decreasing order. And then take the absolute difference for each column, sum them up. I guarantee that the sum is always equal to 25, which is 5 squared. So in any partition of the first 2n natural numbers, which is 1 to 2n, into decreasing and increasing sequence of n number each, show that the sum of absolute value of the difference of the corresponding numbers of the two sequences is always n squared. In our example, n equals to 5. Now, let's understand again from the first example. The absolute value of 2 and 9 equals to 7 is actually equal to 9 minus 2. For the second one, it is actually equal to 6 minus 5. The third one is 7 minus 4. The fourth one is 8 minus 3. And the last one is 10 minus 1. What can you observe here? Similarly, for the second example, 9 equals to 10 minus 1. 4 is 7 minus 3, 1 is 6 minus 5, and 4 is 8 minus 4, 7 is 9 minus 2. Is there any common for these two examples? Do you notice that the first numbers is always equals to the second half from the digit 1 to 10, which is 6, 7, 8, 9, 10. So we may ask, is this always true? If that is the case, then it is very easy to understand that this sum is actually equals to 10 plus 9 plus 8 plus 7 plus 6 minus 5, 4, 3, 2, 1. Direct calculation will give the answer 25. For each column, the A and B, one must come from the first half, 1, 2, 3, 4 up to n, and the other one must come from the second half, n plus 1, n plus 2, all the way to 2n. Now, we need to examine whether this is true. So when we select the number a1, a2 up to an, it must be in increasing order, meaning that a1 is less than a2 less than a3, and so on until less than an. the rest of the number we call it as B1, B2, all the way to Bn. And in this case, it is decreasing, meaning that B1 is greater than B2, greater than B3, and so on until Bn. Then we claim that the number in the same column called AK and BK, one of it must come from the set 1, 2 up to n. The other one must come from n plus 1, n plus 2, all the way to 2n. Suppose this is not true. We may have the assumption that both AK and BK come from the same set. Example, they are elements in the set 1, 2 up to n. So example, this is AK and BK. And what does it mean? Since AK is an increasing order, it will mean that all the elements before AK must belong to this set 1 to n. And also, BK plus 1 up to Bn also belongs to the set containing 1, 2 up to n. It is easily see that there are exactly n plus 1 of them. But in the set of 1, 2 up to n, there are only n elements. And this is impossible. So meaning that the assumption of AK, BK in the same set 1, 2, 3 up to n is impossible. Using the similar idea, if we let AK and BK in the same set of n plus 1, n plus 2 all the way to 2n, we will also contain a contradiction. This shows that no matter how we partition the first 2n natural number into two sequences, one increasing and one decreasing, the sum of the absolute value of the differences of the corresponding members is always n squared. And this problem beautifully illustrates the power of combinatorial thinking and the elegance of mathematical symmetry. That's all for today's lesson. See you again next time. Bye bye.